Okay. Who cares if it works? I don't know. I don't know if this is going to be any better than last time, but I tried to make things better. May have not worked. This is probably too loud. I don't know. I usually have oh, I can go louder. Oh, nice. There we go. Yeah, I usually have easy effects when I'm trying to be easier on my computer today. If anybody wants, well, I mean, I'll let people fill into the stream before I start, yapping about that. But if anybody does end up wanting my theme, I don't have it on GitHub yet, but I do have the file that I can give you. So if anybody gets interested in that, then I think it's a really neat theme. I made it because my other theme that I made was just not readable enough in terms of streaming, I noticed that it was just really hard to see. Hey Arya, what's up? So I made this one, and I do really like it. So that's what I'm using today. Goal of today is to unincrementalize. I went overboard with my eval incrementalization. Right now I have mobility pop counts that I need to get rid of. The idea behind that was to streamline things so that we just add mobility in. But I'm realizing that we can't do this if I want to, have safe mobility be a thing. Then I have to actually wait until we have attack masks. So doing pop counts incrementally is only going to hurt us. So that's what I have to do, is unincrementalize that, and then go back to actually, doing this mask here. That I thought that I wanted this, but I looked at some other people's code bases, and then I realized that they just did this and they didn't do the incremental pop counts, and so I was like, okay, fine, that's fine, I'll do that. And the goal for today is to implement what's known as lazy evaluation, which is, we're ready for it now because I've incrementalized a lot of things. And things are pretty modular now, where basically our lazy eval function is going to be none of this stuff, none of the king safety, none of the fancy, pass pawn stuff or any of that. It's literally just going to be us iterating over the pieces, computing the mobility, which should be simple enough, doing maybe the threat stuff, since that's kind of a simple calculation, and then doing, we already have PSQT incremental. Other than that, I think it's literally just that, and then pawn stuff. Since pawns are hashed, then that should be easy enough to put into lazy eval. The whole point behind lazy eval is we're trying to reduce the work at shallow depths. So like at depth 0 and 1, maybe even 2, we want to do a lazy eval, which is not the full eval because it's at so low depth that it doesn't need to be 100% accurate, because with all the pruning, we're never going to be 100% accurate with our eval. So we're basically just estimating. And people say that this really speeds up an engine, so I'm kind of excited for it. But I have attempted implementing it before, and it sucks. So it made my engine very dumb. But then again, I didn't have a lot of things incremental back then. And so it was literally just PSQT material, there was no mobility or pawn, hashing or any of that stuff. So hopefully this is going to work, but not really sure if it will. But as far as the elo of the engine, it's kind of been regressing lately because I've been doing like an insane amount of tests with it and trying a lot of weird stuff out. One of the weirdest things that I've tried recently is this kind of futility gate that was inspired by what I saw in Kohai, that basically establishes if the node is so far under alpha that we can prune inside of it, and this has stabilized the search, but getting the margins to a point where this works took a long time. And there was a lot of experimenting and a lot of just trying things like this and etc. But we're at a point now where I think it's pretty stable. I'm still not sure if singular extensions are actually an elo increase or not. It's like about even. To be honest, I barely understand how it works as well. It's like super confusing to me. Recently I also removed futility pruning. Futility pruning as in like the real futility, as in pruning quiets. Reason being, attached to it is this eval here, and doing this eval was way too expensive, and it turned out to be an elo increase to just like get rid of it. And so I was like, okay, well, I mean, I'm fine with that actually. So anyway, so all of that is what I've changed. I've reduced some of the margins, like the razoring margin I brought back up, and the RFP margin I brought back up. I don't understand how other engines are able to do RFP at like 30-10. It's like ridiculous to me, but or razoring at 30. It's just always elo decreases for me. I don't understand how they get away with it. Also implemented recently core hist, which was a pain, and it's not like full core hist. It's actually only pawns right now, but yeah, the plan is to do core hist with all of the different pieces, but the pain is the overhead of incremental hash keys for every single piece type, which obviously we don't have yet. And once we have, there's going to be overhead. So the question is, will the gain be worth all the zoring that we're going to have to do during make and undo? And the truth is, it probably isn't for now. Like maybe when our eval is more set in stone, then this will be more worth it to do for stuff that isn't pawns. But pawns is where core hist started, like the idea. It's corrective history. And the idea is to take the difference between our eval after the move that is at the end of the node versus at the beginning of the node, and try to influence our evaluation based on that. I think it's a neat idea, but other engines end up doing it with other pieces other than just pawns. They do it with non-pawns. They also do it with king, bishop, rook. It's kind of confusing. I don't really understand why they do it with those pieces specifically, but yeah, they have specific different combinations that they do it with. I forget kind of the explanation, to be honest. The page on the chess programming wiki is not very descriptive with why they do it with specific piece combinations, just that they do it with specific piece combinations. So yeah, there's that. Anyway, I have to figure out where the pop counts actually are for that, and I think I can find that here. Yeah, so here, this mob count is what I implemented last. And so I'm going to get rid of this. And this was, what it was doing was, it was knotting with our pawns. So the idea was that we don't want to give bonuses for defending pawns because that's not really something that's super important. And so that was the idea behind that. Was but other engines do what I was doing in the beginning, which is only counting mobility when the squares are safe. And to get that information, you have to kind of be during eval. You have to make that attack mask. Making it incrementally is just too slow. And so therefore, doing these pop counts incrementally is absolutely out of the question. And so I'm going to go into this like piece info struct that I made and get rid of that. We can actually just like commit to it and just press D. I don't understand why I have I get so scared of deleting things and I comment stuff out and then my code becomes full of comments that are just, pieces of code that I'm just a hoarder is what I am. That's the type of programmer I am. I'm a hoarder. I just hoard code. And it makes it impossible to ever put on GitHub is the problem. So we're trying to avoid that nowadays. Okay. So instead of having the mob count, we are just going to have the mask with the attacks. And this should still already be incremental. It should be absolutely still piece attacks equals attacks. It should just work. Still, I'm hoping that there isn't something I'm forgetting. But yeah, this was a pain to do actually, the incremental mobility. Like I was really, really annoyed implementing this. I was like screaming at my computer actually. I was really mad. There was a lot of difficulties that I had with this because the problem you end up with is you can't recompute masks multiple times for the same piece, and so you have to have this undo mask that is incrementally getting updated with pieces that you have already recomputed, which it took a while to figure out that this was the bug actually. And it is kind of painful. So for example, when you castle, your rook moves, right? And then you want to recalculate all of the sliders that may be that may have intersected where that rook was or where that rook ends up, because you want to update the attack masks, right? And so you have to do that for all of the 4 squares, where your king starts, where your king ends, where your rook starts, and where your rook ends. However, you have to keep this attack mask to make sure that you don't recompute twice. And the reason why is because if you do, then we will restore the masks twice, which is problematic for other reasons. But yeah, so this is why we have to actually do this, which is basically pushing all of the pieces onto the mask and do this. And it ends up being much more expensive than I thought it would be. So do you plan on what I'll do after the chess engine? That's a good question. I think I'm just going to return to the game engine probably. I've already kind of started poking around in the game engine code base again. That was the plan, was to always return to the game engine, but I don't know. I really want to finish a project, and like my goal with this is to, get it to a really good spot. And I guess my thing is like, it's so much easier to finish this than it would be to finish the game engine. And so I might as well just finish this, because if I don't finish it now, then who knows when the next chess engine I make is going to be, Have a good night. How am I? I'm good. I'm kind of in a weird mood. This old friend of mine texted me out of the blue, the other night and just said hi at 3 a.m. You know, bizarre, to be honest. I think after like 3-4 years, you kind of like lose the right to just hi somebody. You kind of have to have like a, you know, want to catch up or something, you know, tagged onto there. You can't just like, you can't just hi me. That's not right. But, you know, believe it or not, she hied me. And then she didn't respond when I responded. So, I guess it was just, attention, or I don't know. Anyway, that's kind of got me in a weird mood. Anyway, I think, so this is enemy pawn attacks, and from what I saw in Kohai, which is an engine that I really like, no enemy pawn attacks, just do enemy attack mask, actually. And I think I'm just going to trust them on that and not really, you know, worry too much about it. I had this safe mobility separately, which was, I basically had two different masks, right? I had this the safe mask and the regular mask, but I think I'm just going to only count safe mobility now, because that's what they do, and I like copying people, I guess. I don't know. Typically, I think if somebody else does it, then it must be kind of a good idea. Anyway, lazy eval, what I was setting out to do, I guess I can do now since I did that. And so I guess I'll make a function at the bottom. Okay, here we go. I have no clue what we're doing here, by the way, but we're going to try it out, I guess. Oh, I have to put this right. Okay, so we are going to do the pawn hash, so we can literally just copy this because this is going to be the same. We obviously aren't going to copy these all the masks and stuff, but we're just literally going to get the thing. Okay, so we don't have to, well, I mean, we can do this actually. We are going to need search data. Okay, so we don't need this because it's lazy eval, right? We are trying to be lazy. Oh, this is kind of annoying, actually. Well, then in this case, we'll just make these masks down here. Since we aren't caring about them. But yeah, we do have to actually make them because unfortunately we have to actually calculate pawn structure if it isn't already hashed. So that's unfortunately what has to happen. Okay, so this we don't care about. Okay, so hopefully that's that. Okay, so unfortunately we also have to generate the attack mask. I think that's necessary to do our mobility, and I think we want mobility in it, or else I think it's just going to be too lazy. But I'm not really sure. We can try it with both, but I have a feeling that it's going to be too lazy if we don't have mobility in it. I mean, maybe not. I don't know. I kind of, at least for testing for right now, I would much rather be like sure about it than... Okay, so we can't just put in evaluate material, unfortunately. We can't do this because this just is this now. We can actually just like straight up delete this stuff. I don't want to, just in case. But all this does is it just ores the attacks onto one mask, so that we can figure out, what is an attack and what isn't. Obviously we use it here. And so I'm just going to make a function that just does lazy material. Okay, so I'm just going to... Now, how much of this do we want to save? I guess forget the outpost stuff and just do mobility. Because all of this anding and stuff is actually expensive. So we probably don't even want to do the threat stuff, to be honest. Because this we loop through and pop bits, and it's like, it's expensive. We can literally just do this, I think. Yeah. It sucks that I can't actually test this stuff in SPRT on stream, because it actually takes up all of the memory on my computer to SPRT, even with one concurrency. It's too crazy, which sucks. But that is what it is, I guess. And we will take in that enemy attack mask. And mob MG, mob EG will just take in pointers, and I think that that's literally everything we're doing in here. What I do is I oh yeah, it's mad at me because I didn't. What I do is I just assign it at the end. I guess it's more efficient, I think. I mean, I don't know if it's less instructions. I'm just kind of assuming that it's less dereferencing, right? And I think if we're just doing this, then we don't actually have to return anything from the function. I think that it's literally just this. I think. Let me see. I feel like this is too little, but I guess it's supposed to be lazy for a reason. I don't know if I'm supposed to do the threat stuff. My mind is just too expensive. Because if we do the threat stuff, then we also have to do TDP, which is all of this, which is a lot of stuff. I mean, I guess it isn't that bad. Like, technically it's, what is this, like, a few operations, I guess. It's not a pop count, which is, which would be bad. It's, it's kind of just that. But I mean, let's just keep it minimal for now, I guess. I don't know. Okay. Oh god, yeah, so I have this new whatchamacallit, this new Linux installation, and it's all of the Helix stuff, I lost my config for Helix because I just was stupid and I didn't back it up. And so it's been really painful to have, like, I have not really figured out what my configuration was like beforehand. I kind of took it for granted. I was like, yeah, I mean, all this stuff, I'll figure all this stuff out, you know, from scratch. It'll be no problem. But it's like I haven't had the patience to go through the documentation fully and figure out like why when I type in a function, all of the stuff prints out the variable types and stuff, and it's annoying. Okay, so this is going to be B attack mask, and then this is going to be white attack mask, and then this is going to be B. Okay, and we will just make those variables. Okay. Why is it so quiet? This it was very quiet. The other thing was plenty loud, and then this was super quiet, which is strange, but you know, whatever. Okay. So we have that. We aren't doing this. We aren't doing that. I guess we shouldn't have to, right? And so we just have to add the stuff up and then just do this, right? I think so. Who knows if this is going to be an elo increase? I have no clue. So right now our eval is actually 30% of our perf. So if we can get that down to like, you know, 15, that would be huge. Anyway, so our mg plus equals the white mg minus the black mg, etc. Okay. Hopefully. Why am I doing side? I almost made a big mistake there that I would have never caught that bug. Oh gosh, now it's getting loud. Now it's really loud. Okay, chill out. All of a sudden it got super loud. Okay. Okay, so now we just have to do this. The max step, I was playing with something, but it wasn't a good idea, it turned out. And we also have to do the scaling thing. Okay, so I mean, technically speaking, this is fine. And now the idea is, if we don't have a full eval hashed, then we just run this if the depth is 2 or less. Apparently, I'm not really sure, but we can try it out for sure. So let's just go to where that is. Okay. So the idea is that if our depth is less than or equal to 2, else we will do a full eval. And we're only going to hash the full evals, of course, because we don't want to be polluting it with lazy evals, I think. So yeah, this is so annoying. Like, who would ever want this? Who would ever want to do this? This is so annoying. Whatever. So this is literally, I think, the implementation, hopefully. And then apparently, this sounds so crazy. This sounds so crazy to me that in Q we're only supposed to lazy eval because it's permanently less than 2 depth. I really don't understand how that is, how we can get away with that, but apparently we can get away with that. I don't know. It's hard to actually read other people's code bases because half of it is neural network stuff that you can't actually, understand. So, but this is what it says on the wiki. So that's what we're going to do, and we will see what this does performance-wise, I guess. I think that's it. We can do a compile of this as it is, I think, and try and see what this ends up looking like. I think that this is good. Okay, so let's give this a shot. I also have fish now, so I'm no longer a caveman. Which is nice, I guess. It's cool to have terminal autocomplete. It's just, I'm not used to it, I guess. Okay, this is taking forever. Okay, here we go. Okay. I'm not gonna lie, I'm not, noticing like an insane performance increase. I guess we can perf it. Also, I apologize because my I keep on God, I'm super out of it today. Okay, so 19% is lazy eval. And now only 1% is actually evaluate. That seems really bad. That seems like all of it is lazy. I feel like that's got to be bad. That has to be bad. But anyway, I'm kind of wondering now what it would be like if we did it without mobility. But if we did it without mobility, If we did it without mobility, it would probably be pretty fast. I don't know how efficient it would be, but it's kind of hard. We could try to do a SPRT. I do have a different streaming setup today than I had last time, so we could try it out, but it is right to be cautious. I do notice that we are getting okay moves, so I think sign-wise we did everything correct. I don't know if this is going to be an elo increase like I thought it would be, though. Like, technically speaking, we could try to do it like this and see what this is like. But I don't know. I feel like the whole point of making mobility incremental is to actually use it. But, whatever. I also plan on making like a video about making a chess engine. I kind of like want to get other people into making chess engines, before my mind just goes away from chess engines completely. Okay, now we're getting completely different moves after that. So maybe I'm not so sure about that. Maybe I'm not so sure about this one. Now we're getting completely different moves without mobility in there, so I feel like this is actually pretty important. Yeah, without that, it goes down to, well, it goes down so far that it's no longer has a symbol because of the inlining. So that just tells you how insignificant it is now. Yeah. Believe it or not, pop counts are expensive, man. Very expensive. Very expensive. Yeah. The funny thing is that it's a trade-off, because just because it takes less, CPU time technically, it doesn't mean that it actually makes us any faster, because we are cutting less nodes because our eval is less detailed. It's kind of the trade-off that you have to recognize with it. So it probably isn't even worth it to get rid of it, to be honest, because we aren't going to get any depth out of it, at least how I'm thinking. So we can go ahead and test this against the other version without it, and then test it maybe at just depth less than 1 and depth 0. We can do that. So let's give that an attempt here before we okay. This is going to be an attempt, and if my computer crashes, then you can't say that I didn't try, We're doing one concurrency because I have a laptop. Yeah. And hopefully this is fine. Okay. Pray for me. We could also try running it with, if this gives us problems, we could try running it with less memory. We don't actually have like our TT size is actually just hard coded in, so it'd kind of be annoying, but I mean, I could literally just go ahead and change it. But I mean, this is going to be kind of slow, watching the tests go by, but I just kind of want to see a few games to see if we can beat it. The old build is 12 and the new build is 14 with the lazy eval. And if this test doesn't pass, then we can try it only at depth 0 or depth 1 or depth 2. But this is what I read. I also remember when I was talking to people about lazy eval, they were like, oh yeah, my engine got so much better, when I implemented lazy eval. So I was like, maybe I should do that, But maybe I have to tweak it a bit. I feel like you can checkmate with 2 bishops and a king, right? That is possible. Has to be, right? Maybe it isn't. I feel like it's possible. Well, I guess not. Or maybe it just, couldn't think far enough to see the checkmate. Because it is like a ridiculously fast time control. Anyway, if this does end up, passing or whatever, which it looks like it isn't, I also wanted to start working on getting hash keys for every piece. I only have pawns right now, but if I want to implement core hist on different piece types, then I'm going to need a hash key for every single piece type. Yeah, so that's going to be kind of a pain. It's taking a long time to find this checkmate, actually. Yeah, it took really long to find that checkmate, and that's the version with lazy eval. So I wonder if that has something to do with it. I wonder if I shouldn't. I feel like it wouldn't even matter the laziness of the eval when it comes to checkmate though. Like I was thinking maybe I shouldn't lazy if it's a mate score, but I think it might not even matter. Yeah, it might not even matter. Like you could literally like make a condition here like you could literally do that. I just don't think that it matters. It's cool to see it win a game though. I can't imagine that this is good though, you know. I don't understand why he isn't. Oh. Yeah. It doesn't seem like an elo decrease or an increase, which to be honest is kind of what I expected. I mean, maybe it'll take a lot of games to make sense, but yeah. I mean, typically SPRT tests do take, you know, the full 200 to 400 games to get anything out of it, but yeah. Anyway, I think that where are the pawn randoms? Are not in this file. They have to be in here. Okay, well, they don't have to be in there, actually. Where are these things? I can find it from main, I'm pretty sure. Is it in here? Yes, so it's here. So I have it for the each side 64. And we need to do this for every piece, but I think that we can just use the same randoms for hashing. We don't actually need different ones. And so we should probably just like name this piece random instead. Now that's going to be an annoying refactor, but that is what it is. That is going to be annoying. Because I don't actually know where that's referenced. Oh, it's referenced here. That's not the only place where it's referenced, actually. It's referenced a lot. So I'm going to have to like shift R that all the way down in this file. So to set that up, what I will do is I will make one piece random, and then we will copy it and then search for pawn random, the full thing, and then just shift R all the way down. Excellent. Okay. So that's that. We also need to do that where I generate the randoms. Computer programming? It is computer programming. It's chess engine programming. Okay, yeah, I have no clue where I do that. Okay, you know what? When we compile it, that's when we'll refactor it, because I actually have no clue. So it seems to be an elo decrease if we're going to trust what the test is saying. Of course, it's plus or minus 200 elo, but it's not looking good so far. But we're just going to kind of ignore that and pretend like that's not a thing. Anyway, the thing is, we have these functions now, put piece and remove victim, that do this this stuff for the undo, where we basically change our attack mask out based on where the piece went to, and so that's like a part of our incremental stuff. Now we just want to kind of append onto here, updating the hash key. The reason we want to do it here is because it'll make things nice and tidy, because we need a switch case on on we need a switch case on piece type to get the right key that we're hashing into, unfortunately. So we need to actually make the different key types, though. That's something that we have to do. And that's going to be in here. Here. I have to find... Okay, so we need to make a... I think that they have keys for both sides. I think that that's how they do it. So I don't think that they have pawn keys for just one side. I think that they have them for both sides. So I think that it's absolutely fine for us to just do, oh, the ship is sinking, as in my CPU is sinking into sadness. So we might have to bail out on the test if the lag continues. I can't imagine that my my webcam is very expressive right now in terms of delay. Anyway, so that's it, and then we're just going to space Zor for each of these. Yeah, we probably have to bail on the test. It's probably something that I just have to test after stream, to be honest, because it is like, over, a gig and a half of memory that is being eaten up by running two instances at the same time. Anyway, the lag seemed to go away, so we're just going to ignore it for now. So this is this, right? And then this is this, right? I think we just want to roll this into that put piece function. I don't think that there's somewhere else where we won't want that. So I think that that's fine. The annoying thing is that we were doing this efficient thing where we keep these keys local and then only replace them at the end. And so now the question is if we want to pass that into a function and actually duplicate it again, which I don't really know, how inefficient that would be, but we would have to do that for pawn key as well. And then you would just end up with a bunch of keys that you're passing in and duplicating. And I think that that's not what you want to be doing. I think that you just want to be working with pointers completely. And so we might just get rid of that then, in that case. Yeah. Okay, so in that case, what we're gonna do is I have to move this to the start of the function. The stuff that takes the undo, right? So the undo basically just stores the old stuff that we're gonna replace when we undo the move. And so a part of the undo is now going to have to be all of the different keys that we need to undo, which we're just going to have to literally list them out. The ones that I just made. All of them. Boom. Okay. Okay, so put piece will call a function called update Zobrist, I guess we can call it. Oh, actually, God, it would be so efficient if we could just use the same switch case for both. I'm gonna hard code it. Yeah. Yeah, we're not gonna make it. Yeah, we're not actually gonna do it the clean code way and make another function, but because we just want to switch case once, and that's just gonna be the way it is. I'm sorry. If you came somewhere for for clean code, you're not gonna find it here. Anyway, the goal here is now to XOR the current key with the the pawn random, but yeah, okay, so what we will have, if I can go down here, oh, the issue is that we have no way to find where the start is, and so we're just going to have to take in a start argument into this function, unfortunately, which is going to be like somewhat tedious to refactor, because whatever, we'll just do it real quick. There's no, it's fine. Yeah, so we have to go through and fix all of these now, because they need to take in a start argument, because we need to obviously remove it from the start and then put it at the end, obviously. So yeah. But after we do this should be, believe it or not too painful. Okay, we have to stop. We have to stop it. I can't deal with the lag. I cannot. I can't code like this. It's absolutely necessary to kill it. I'm sorry. I'm sorry. For the sake of my CPU and my sanity, it has to end. And we're ending it at a loss, unfortunately. But hopefully the more tweaking I do with it later, I can get it to be an elo increase. Maybe we just lazy eval at depth 0, or I roll in the threat stuff as well. Or I make it more lazy. We I need to do more testing, but I can't SBRT on stream, unfortunately. So now I have to update the keys. I mean, technically we could actually just like not even switch case, and we could just make it an array. Yeah, why don't they do that? This is the exact structure I saw, by the way, in Yukari, and so that's why I kind of defaulted to go towards this, and I didn't really like even kind of consider doing it in an array. But I don't understand why it wouldn't be in an array, Like why not? Okay, we're putting it in an array because that's what programmers are supposed to do. At least that's what I was taught. And if I regret it later, then that's on me, I guess. Anyway, then we don't need a switch case. We still are switch casing, so it doesn't save us any work, but it is going to save us work when we remove victims, because then we don't have to switch case. So technically we are saving branching, so it's not all pointless, right? Anyway, I know I'm going back and forth a lot, but I do have to copy the code here for this. We want to copy that into here. It's called P. Okay, so there's that. And now we need to do the actual piece key. And then XOR that with piece random No, not P. Yeah, start and then pause. Yeah, exactly. Okay, so what this is doing is it's doing Zobrist hashing updates on our start position and our end position for the piece types. And we want to do this exactly for the victim as well when we remove the victim from its end position. Unfortunately, we also are going to have to take in a side here to be able to do this. But yeah. Surprisingly unpainful implementing this, at least so far. I thought that this would be kind of annoying, but it's not that bad. So we need to take in that argument, which that is kind of annoying, but whatever. So that's going to be not side, obviously, because it's the victim. Oh, yes, you're being annoying. Wow. I actually hate it when it's this annoying. We're just going to call this enemy side. The reason why we have to do this is because of inlining. Because of inlining. So that we don't have to cast it every time. So you can thank the compiler for that. But I'm not casting every single one. Yeah, you know, I'm not that crazy. Anyway, this has to go to capture square actually, so that's why we're going to do enemy side like this. I also have to get the music. I am not listening to Chill Hop today, unfortunately. Sorry if you're a fan of the Chill Hop playlist. I just wasn't I wasn't up for it, you know. I just, you know, it's just not the type of day for that, you know. We were brave and we did cast here, but we aren't doing that anymore. And so we are now going to get rid of every place that has a P key or a key, because we are doing this inside of the function. And technically this is going to add a bunch of overhead, but according to also, this is not start. I almost made a big mistake there. This is actually rook castle location side, castle side, start. That's what this is. According to people much smarter than me, this is going to improve the elo of my engine once we implement all of the different core heuristics. So I just have to kind of trust them, I think. I should stop talking before I actually make a bug. Because I probably will. What's going to happen? Okay. And this function actually used to be about 5% perf, and now it's about 8% because of all of the extra stuff that's going on to make everything incremental. But I think it's worth it. If it's extra work, it has to be worth it, you know what I mean? Okay, so also get rid of this. Wait. Okay, never mind, we can't get rid of this. Okay, don't be stupid. Do that. Okay, don't be stupid. Don't be stupid. Okay, so we do have to do that, and we also have to do this as well. We also have to remove from the bottom where we set the keys, okay? We also have to remember to do this now. and we have to remember to change. Okay, so we have to do some searching here for all of the keys. I just messed up. So we're just gonna do that again and pretend that that didn't happen. Yeah, so we're just gonna go here and we will do game key instead of key. Okay, fantastic. This is fantastic. Okay. Technically, a optimization we can make would be to replace all of not sides with enemy side. I think it's technically one less operation. I don't know if the compiler would just automatically do that, but you know, it's very possible that it does. I don't make compilers, so I wouldn't know. Okay, we can work on that later. So I think that's it. Keyword think. But technically that should work. I have no clue. We can test it. I do have a function called checkhash, which checks a hash key that makes it from scratch. However, I only have it for pawns, but technically pawns should be the same as any other piece. We of course have to change this to piece key pawn. So we can check that out and see if it's all good. Of course, we do have some errors in here. So obviously this is going to have to be piece key pawn. And I'm just going to copy this and then replace all of the game pawn key. Yes. Okay. So that should be fine. We can check hash. We are probably going to hit a compiler error here though. If we don't, then I'm incredibly lucky. Yes. In main, not in main. Main search and game.h. Okay. We were just here. How did I not notice? Okay. So when we restore keys, we of course have to do game piece key pawn equals undo pawn key. And of course, first of all, we shouldn't even have these. Second of all, begrudgingly, I should actually just have it as an array inside of the undo struct as well. If I'm going to have it as an array outside of the undo struct, that just seems accurate. And so now the question is, do you want a mem copy? Probably not. I don't think that's what you want to do. There is probably a better way of doing this. Queen. Okay. I'm actually going to do it the better way. Oh, Helix tricks. Oh, that's crazy. All right. Okay, so now we just need to do the exact opposite on the other side, on the undo. So we need to replace all of the games with undo. And the reason why I did that is because now we can go over here and do the games like that. Fantastic. And we can get rid of that. Okay. So that technically should be the thing. Hopefully. Okay. Let's see if we okay, so we still have some things. Main.c main. In main, really? Oh, interesting. Okay, okay, listen. We should really do this on UCI new game as well. So we can make a, once again, begrudgingly make a function that does this, that just resets these to 0, which I think is somewhat necessary, unfortunately. I've never listened to this album before, by the way, so I have no clue what's going on. It does seem kind of cool, though. I like it. There's a lot of static, though, which is, you know, a thing. Okay. Insane helix trick. Crazy. Now we want to reset piece keys. And we will call this on UCI new game. Yeah, we were already ahead of ourselves on that, and you know, that didn't have a semicolon. It didn't. Okay. Okay, so search.h, search.h, okay, so obviously this is, you know, just piece key pawn. Okie dokie. Game.c, there is an error here, so okay. I think that this is everything. No, this isn't everything. It's in move generation.c. There's also an error. So this is piece key. That was by side. That was by side? Wait a minute. Did I do this bad? Don't trip yourself out. Don't trip yourself out, actually. Was that by side? And I didn't make everything by side? That would suck. No, I did make everything by side. I'm just tripping myself out like insane. I was like so worried, but I this is actually completely accurate, actually. Okay. I was freaking myself out there. Okay. Are we free? Please? Okay. Well. Okay, there we go. Okay, yeah. Gosh. Okay, so on a promotion, we have a Zobrist misalignment, which is good. I'm glad. I'm glad that we had that, because now Okay, so I'm glad we checked. We did the check hash because there was a bug. We made a bug. Oh. Okay. That's why. That's why. We have to make an extra boolean here. There's actually no other way to do this other than put a boolean to see if it's a promotion or not, because we need to toggle a pawn rather than toggle whatever promotion it is, which that's really unfortunate that we have to do that. That is just simply what we have to do, and we have to. Your message was retracted. That's unfortunate. Yeah. Yeah, I mean, actually, if we want to completely eliminate branching from this, actually, we could just like take in a secondary piece type, piece type. Can I just do end p, which is going to be the piece type that we end as. No, you want the start p. You want the start p because the end p is the one that we're using for everything. So this is going to be the piece that we start as, which we will use here. Excellent. Okay, so that's exactly what we will do. Okay. Now that's going to be kind of annoying to refactor, I'm not going to lie, but it is what it is. Because all of these, except for promotions, are literally going to be piece. But this eliminates branching 100%. So it is, it's not bad. It's not bad. It's just kind of annoying, I suppose. And then, so this is going to be the start piece will be a pawn, right? Okay, now let's try to check hash again. It takes forever to compile when I'm streaming, to be honest. It's kind of ridiculous. But that's my CPU for you. That is my CPU. Okay. Okay, our check hash is coming back correct. Now, do I trust that it works for every piece, or do I want to actually go through and do the check hashes for every piece type? Now, I mean, that's kind of a pain, but I mean, it wouldn't be the first time I've made a bug like that and then just like, not want to actually, cross my T's and dot my I's or whatever, that it wouldn't be the first time that I've made an oopsie. The annoying thing is that I would have to make the function that does that creates a pawn hash from scratch for every piece type. It isn't bad. It isn't bad. It would just be literally just create piece hash from scratch with piece type p, and it's just literally going to be the same thing, just for the piece type. So there is that. Okay, that's literally going to be it, and then we will just return the key. Okay. Return the key. Okay. So we're just gonna for loop it. This is just going to sit here as debug, okay? I know it's ugly. So be it. So be it. So be it. So be it. So piece hash from scratch. Oh man, this isn't in a header. Like, what was I thinking when, like, I'm such an interesting person. Whatever. Yeah, this code base is getting to the point again where it's like truly untenable. The amount of buffers I have to have open to navigate the code base. It's kind of annoying. Okay, so this checks every single piece key now against the create from scratch one. So hopefully that's going to work fine. Okay, we instantly died. Let's print out the piece key. Piece. It's actually called pname. I have it as I. So let's see. Yeah, let's see. It looks like it would be a pawn key, but we just check the pawn keys. So unless my function that I wrote is wrong, I did kind of make it willy-nilly. Oh, this is P. Oh, no, it isn't. Oh, this is P. Wait. Wait, was this never correct? What? Wait, was that always bugged? Oh no. Wait. Oh wait, no. I'm dumb. I thought that I was okay. No. I'm dumb. They're the same randoms for every piece type. I'm driving myself crazy. This should work. So if it does work, then it so it says that it's for a night. The night key is broken. And I'm assuming that this is on undo. Does it, no, it gives me game key, which is not correct. We want game piece key. Sorry, I keep on compiling this to see, but okay, so it appears that there is a legitimate bug with what I just wrote, which is unfortunate, but but the interesting thing is that the pawns are fine. The pawns are fine. Why would the pawns be fine, but something else not be fine? That's strange. Our key is 0. Oh, I know what's happening. I know what's happening. We're not initializing them. We're not initializing them. That's why. Okay. Yes, so we create pawn hash from scratch. So actually what we need to do is we just need a for loop through all of the piece types and then create the piece keys. I almost forgot about this part. Whoopsies. Okay. That should fix the bug. Because our piece key obviously can't start at 0 because starting position isn't at 0. Obviously. Obviously. Okay. We seem to be doing well. It's hard to tell because I'm streaming, but I wonder how much of a performance hit we've taken from doing all the hash key updates for piece types. We can run a... Oh gosh, why is it... Why? Why are you like that? Don't you have a timer for your move? Oh, I did do this. I did do this because I was testing. We're just going to ignore that. Okay, so the main thing is that the check hash came back correctly. So all of the keys are working properly, which is exactly what we care about. So that's exciting. Now the question is, what do we do with them? Well, what we can do with them is go into our core hist and start implementing all of the other things, right? And so I wonder if I'm going to have to look at how exactly Yukari does it, but I think they do it like I think that they just do this. I think that they just do this at update time. I don't think that they do this incrementally unless I'm stupid. But if they do it incrementally, then I don't know. Maybe they do. I'm not really sure. I think that they do it like this, right? And you just OR them together. Yeah, it has to be. Wait, hold on. How do they do it per color, though? Also, this is Zord as well. This is Zord. But I might actually have to look at the source code right now for myself. To see how they do it. Hash non-pawns, which is a function that does it from scratch. It computes a non-pawn hash from scratch. Do they do it from scratch every time they do this? Is this really? It looks like they do it from scratch. They actually do it from scratch every time they update. Wow. So the rooks, queens, and kings, they do what we were about to do, which is Zoring just the keys. So what we did wasn't, for nothing. But yeah. Okay. Got it. Got it. Okay, so let's do that then. So let's just get the and let's get the king, queen, rook. So this is both colors, is what it is. So we won't worry about the non-pawn yet, because I think that one might be the most inefficient to compute, if you know what I mean. Like, this is king, bishop, rook, right? I didn't just, it's queen, king, rook. So this is king and minor versus king and major. That's what it is. Let's do it in the same order. Okay, and then we are going to index it the exact same way. Right, we have to also make, okay, before we do this, we have to actually make all of the different core hists for this, and then we'll set up the non-pawns just for the future. I think that you can just do that. Anyway, we have to, unfortunately, go through and probably do the mem set. Yes, we have to mem set. Also, hold on a second. This is yeah. Wait, no. It wait a second. It is interesting. So they do have different core hists. I mean that kind of makes sense actually. So you know, it is what it is. So that is cool. But yeah, I obviously I was mem setting this wrong the whole time. So I'm glad that I caught that. Whoopsies. Whoopsies. I wonder if I can look at the source code actually right now to see, they do have two different ones. Interesting. So you also hash it for the enemy side as well. So we will just have one for white and black and just copy their homework and not really have anything on our conscience about it. White, black, there we go. Okay, so back to what we're doing here, which is doing this. So let's just call it that. KB and P as in pointer. And I think that this is exactly the same as this. I think. Okay. Now we can also do the non-pawn thing. Reason why I'm not doing it is because there might just be too much overhead for it to be worth it to do right now. There probably is too much overhead for it to be worth it, but we can attempt it. I just looked at their source code and they literally do it from scratch. So, which, you know, there's a lot of looping there. For rook in piece mask of rooks. And then they literally pop bits, I think, to do it. If I'm seeing this correctly. Self square of piece. And if the queen color doesn't equal color, continue. And then Zobrist add piece. Pieceless get bit. Yeah. This has to be a pop bit that's happening, which is, you know, wildly kind of slow, you know. But I mean, the reason why I look at the Yukari code base is that they do everything super efficient. So if they do it that way, then there must be a reason. I'm kind of now wondering if it's possible for me to do that incrementally, though. I feel like it is, right? Like you would just need another key and then just hash every piece that isn't a pawn, right? Like it would be like 99% the same. So I don't see why we can't do it incrementally. It would have to be faster to do this incrementally. There's no way that it's worth it to not do it incrementally. There's no way. So you know, maybe it's my own stupidity, but yeah, I want to do it incrementally. So non-pawn key. There we go. Yeah. Now how are we going to do this? Well, we will go into our make and undo, and we will do it just like we did the other stuff. We will make we have to put it onto the undo struct. Sorry if that was loud. Maybe it wasn't. I don't know. We have to go into the undo struct and then put in there we go. Now, there is going to be a bit of overhead here because we actually do need to check that. And we can use the same piece randoms. Although technically we don't need side, but I don't think it matters. It shouldn't matter. It shouldn't matter. It shouldn't matter. I don't think that it should. Because they're technically just two different keys. It shouldn't matter. It shouldn't matter. It shouldn't. Yeah. I'm just not going to worry about it. Okay, so this is what we have to do. And I don't know why they do this not incrementally. It doesn't make sense to me. It just doesn't make sense to me. But whatever. Hopefully this works. I think that that's literally all we have to do, and then we just have to restore it like we do everything else. I don't understand why they, you know, maybe I'm just being dumb, but I think that this works fine. Okay. They're a lot smarter than me though, so it's I'm probably missing something and whatever. Anyway, if I did this correctly, it feels so simple, but yeah, we should just be able to literally use it to index straight into the core his thing, without having to worry about it too much. And we will be using the game non-pawn key for white. Yes. Okay. So now we just have to do this for black. We have to do the fancy selection stuff as inefficient as possible because, you know, that's just how I code. Okay, there we go. Okay. Look at that. Not painful at all. All of the core hist stuff. There we go. I think that this is fine. I think so. According to my eyes, it looks fine. I could make a function also that recreates the non-pawn keys, just in case we, you know. I think it's fine, though. I don't really want to make that function because, oh, you know, I have to make that function anyway because we have to initialize them. That's what I'm forgetting. Yeah, that is kind of a pain. Okay, well, whatever. It is what it is. Create non-pawn. And this is going to take in a side instead. And to do this, we are going to yeah, there's really no way to do this other than looping through every piece type. I mean, and just popping them off, I think. Yeah. Yeah, that's just what you gotta do, which is what they do. We're not going to use pop LSB because it's slow. I used it there because I didn't care, but here I kind of do care. So we're going to start with knights. And we're going to do it by side. I want to get the code that does this, though, and that's going to be ctzll. I just copy and paste the code every time, which is nice. Okay, and now we just have to do this for every piece type, and that's it. No big deal. I don't know why I forgot what a bishop was called for a second. I'm pretty sure that non-pawns include king. If it's a non-pawn, I'm assuming that that includes a king. So we're just going to assume that. Wow, this is really serene. I like this. Okay, that was a little bit painful, not gonna lie, but we got there. Now to add it to the header file. Simple enough. And now we need to go to our initialization and put this there. On set board to fen, where we do the other things. We're just going to game non-pawn key white equals create non-pawn hash from scratch game white. And we'll do the same thing, of course, for black. Excellent. Excellent, excellent. Okay. Now that that's done, I guess it's within our best interest to make a check hash just for this. And so that's what I'm going to do now. Just to make sure we're not being crazy. So we will eventually we should just like make a function that does all of the check hashes all at once. It would be kind of nice. But for now, I'm just going to hard code this in as this. So deal with it. Okay. Fantastic. Let's see it. Dang it. I apparently have an extra bracket there, so that's why. And once this is done, that's pretty much everything I wanted to implement, actually. Pretty much. Pretty much. Okay, I'm noticing some performance decrease. There may be a slight performance decrease. Maybe that's just because I'm streaming, but you know, it's kind of like suffering from success. But hey, the check hash came back completely correct, and so that means that our core hist is working for non-pawns. So that's very exciting. It's very exciting. Now we just have to actually put that into the eval. So the core hist eval is somewhere. It's here. It's here, and we have to just do all of them, and then it's gonna look like we're just adding them together before we divide by the grain. So that's what that's gonna be like. Now the naming convention was P at the end, or no, C at the beginning, so that we're gonna follow this. So CNPW, etc. And we will use the non-pawn key for black, or for no, you use it for the color. Yeah. Don't trip yourself up. It's fine. You index it by side? You index it by side. Okay, I'm not tripping myself up. Yeah. We do index it by side. Now PW, what is PW? Yeah, I didn't understand this. So they have all of these different weights, but they're all 1 times 1 divided by 1. Basically, they were all weighed the same in their implementation, and so I'm just going to keep them weighed the same as well. Let's just make sure we're not making a typo here. Okay, so now we have to do all the other things, and we actually have to do the same XORing here that we do here to get the key, unfortunately. But yeah, what we're basically doing here is we are matching our current position of different combinations of pieces to the stored history that we have of where those pieces have been in our evaluation beforehand. And the idea is that we get a more correct evaluation because of it. That's the idea. That is the idea. And then of course we're going to go core hist. BN. Okay. Now all we have to do is add them up. And divide by the grain, and that's it. That is it. That is it. That is it. I think we did it. I think we did it. Now, of course, we can tune this for all of these to have different weights. They had them all set at 1, I believe, in their source code. When I was looking at it, I can look at it again to make sure, but I'm pretty sure that maybe it was just the pawns that were I'm looking at it right now. Well, I can't because GitHub sucks. It just won't take me to where they have the parameters. Oh no, it takes me. Yeah, they have them all literally at 1024 over 1024. So it's just 1. They're all weighed the same. So now we definitely have a massive performance hit because of this all, which is very concerning, to be honest. But everyone else does it this way, so that means that it has to be correct, right? I'm just going to perf it just to see what exactly is bottlenecking us. I can already see that we have, our moves are changing. And we find G1 F3 as our first move, which is interesting. You can't really, because of the amount of inlining I do, we sometimes just don't get actual function names in here. But yeah, I don't see put piece is where it is. Put piece is where it is. So that's at 3%. I don't really know what that was beforehand. We can actually take a look at the old build and then see what it was like before. But yeah, there definitely is a performance decrease without any doubt. Yeah, that was at 1% before. So up 2%. Yeah. I mean, that's not incredibly crazy to think about, but it is something to think about for sure. I wonder how much of the decrease is also the lazy eval stuff and not the core his stuff. I don't really know how to test that. We can test it by literally going through and then toggling the lazy eval stuff off and just testing this for now. Because I kind of want to see, you know, we did test the keys though. The keys are 100% correct, so it must be working. I think that the formula is the same for all of them. Maybe I need to give it a closer look. Yeah, it does just kind of seem like the performance decrease actually just comes from chorus itself, which is incredibly a massive bummer. to put it aptly. A massive, massive bummer. Yeah, it doesn't really come up on the perf. I almost wonder if it isn't even that. I wonder if it's actually just the fact that we're evaling with core hist itself, and that it's not actually, our nodes aren't getting cut as much, and so I kind of just want to try to return raw just to see what that's like. Because technically speaking, it shouldn't be. It's just a few extra Zors per move. Like it's not ludicrous, So I don't think that it should be. Wow. I think that it is just the overhead, like of literally just that stuff. Yeah. Yeah, that's a real bummer. I mean, maybe it'll end up being worth it, elo-wise, but, I'm not really sure. Maybe it'll be worth it, though. I don't know. That was what I wanted to implement, though. But, because everybody else has it, in their engine, so I was like, why not have it in mine? But, This extra branching is also not good, I do completely get that. But it's much faster than they do it, which is creating it from scratch. It's got to be faster, to do this. It's got to be. Okay, well, I guess we can run a test, run a, run an SPRT on it. I suppose. I hope that I didn't just spend all this time implementing this for no reason, though. That would be incredibly, incredibly sad. I don't really know. It's kind of hard to watch chess this fast, to be honest, and like make any critique on anything that's going on. But it's usually a bad sign when somebody is losing very fast, which is what just happened. Or like by a lot of material. It's usually a really bad sign. It's something that there's some bug somewhere. Like being a knight up in this case is just kind of ridiculous. So that's not good. I'm assuming that it's the old build that's up a knight right now. It's kind of hard to... Okay, well that was actually the new build that was up a knight. Yeah, unfortunately I can't run more than one game at a time while streaming, but we are just trying to get a gist of it. So it looks like even regardless of the performance decrease, we are doing well. I don't really know how much elo it's going to be, but we have implemented incremental core hist completely in the last hour, so that's cool. That is cool. I don't really know how lazy eval is supposed to be, but I assume that it's not working for us, which is annoying, you know. I guess we can give it a shot without the attack mask or mobility, right? But yeah, I think maybe core hist will help with that, because it kind of makes up for the lack of eval, maybe. I don't know. Also, we are probably going to have to tune every single margin. That's kind of what you have to do whenever you implement more core hist or whatever. You know, you always have to end up retuning a bunch of things, unfortunately. A bunch of margins. That is the price you pay. It looks like we're dead even. Which is fine, because of course we do have to tune. So it's not the end of the world. It's not like we lost elo, which is what I'm concerned about. was concerned about the overhead being crazy, but if we didn't lose, we're fine. If we didn't lose, we're fine. Yeah, it looks dead even. So, I guess next we can give the super lazy a try. Oh. By the way, when I was toggling things earlier, I was only toggling the lazy chorist, which defeats the purpose of toggling the whatever. Anyway, we can give this a shot. I don't know how lazy people do it, but I can actually look up. Interesting. Okay, so lazy evaluation means dividing all the tasks performed by the evaluation function into two stages. If after performing all the tasks for a given stage score exceeds beta, or if it falls below alpha, the score is returned. The first stage usually consists of the evaluation terms that are relatively cheap, possibly incrementally updated, like material and p-square tables. Interesting. So I thought that we were just changing the static evaluation down, but this is actually playing with the margins, actually. Interesting. And it doesn't say anything about depth here. I'm looking at some code right now. I'm trying to look at some code. I don't know why this code is linked if it doesn't... I don't see the... I don't see the gate based on beta and alpha. I don't see it. Yeah, it doesn't exist. That's why. That's why it doesn't exist. Okay. Well, maybe we should do that then. We could probably put that into the other thing, but yeah, we can try it. We would basically do this. I wonder if you would do anything else other than that. I think you just do that. And then you have some margin play here. Okay, so falls below alpha. Okay. So I guess we can. How big do we want this? It's basically like a window. We can have it at 20 is fine. I think the idea is to just use MG and EG at this point and then return early if you fall within the window. And so what that's going to look like is you have to interpolate up there actually to get the full thing. So if the beta plus margin is less than, I don't understand how math works, so this is kind of challenging for me. We want to be within the window to return. So that would be, it's easier to think of it as PE greater than beta plus margin. And I think you want to OR it with the alpha minus margin. I don't think you want to AND it. According to what it says on the wiki, this is what it is, which it seems like an OR thing and not an AND thing. It says if it falls below alpha, or if it exceeds beta by a certain margin. So that's what this is. Then we just return. Then we just do we have to copy and paste this up there. We should also just be like normal and just return this. I don't know. I had some weird code here that I was attempting something and it was a bad attempt, obviously, because I'm now deleting it. Yeah, this is just the code that we're going to copy up here. So if we are within a certain margin, then we just return this, apparently. Seems ridiculous, but I wonder how much we can kind of adapt to this and move above. We might be able to like move rook files is not expensive, like things like that up there. But we obviously want to incrementalize things more so to make this more kind of efficient. But for now, I think this is fine. I kind of want to give this a shot, but we do have some errors because we need to put in alpha and beta into here. I thought for a second that I put these backwards, and then I'm glad that I looked, because I would not have noticed that I put them backwards. Is this test still going? It isn't. I stopped it. Okay, good. Okay, so let's see if this speeds us up at all. I have no clue what this margin is supposed to be. I try to look at the examples, and the examples weren't very good. So in my debug evaluate, I also need to put in negative int max to int max for the fake alpha beta. Okay. Hopefully the core hiss was worth me going through all that refactor for. I hope so. I think the concept of it is cool, which is why I was really excited to do it. I think the concept is cool. I don't care about the elo. I think it's cool. I like E2, E4. I do not like B1, C3. Not a C3 fan. Yeah, I have no clue how to test the margin, to be honest. We can run a record, though, on it, just to see what it looks like. Our evaluate went from 20% to 12%. Since we're taking in already as argument, we're taking in our search data, we can make a counter, like a debug counter for how many cutoffs we're getting, because that is a lot of cutoffs. Or this went from 30% on perf to 12, which is massive. Which is massive. If I had to guess, maybe 1/3 of nodes aren't getting cut off, right? Anyway, we want to go to search data and make a new thing here. Just so that we can kind of know what's going on. And so that we can tune the margin. I have no clue how to tune the margin other than running like a million SBRTs, which is what I'm going to do after I get off, you know. But let's put this in here. I'm going to put this after aspiration fails. It kind of makes sense to put it there. Search data dot. I forgot what I just called it. Oh yeah, I called it that. Okay, now we have it in our debug so that we can actually see how many are occurring. Though, actually, this doesn't make sense, the or. I think it's an and. I think it has to be an and. Because, yeah, we're going to get like 929. This is basically every node. This is like every node. I think it is and. Because think it is and. I think it's just like an aspiration window, right? Where it's less than or equal to, and then, yeah. I think it's just like that. I don't think that it's or, because then you're always going to get a cutoff, basically. You're always going to get a cutoff. Okay, we have to lock in here. Dude, why can't I find ampersand sometimes? It's crazy. Let me see what moving this margin to 10 does. Just curious. Wait, you would want the margin to be bigger to get less cutoffs. You would want it to be bigger. I wonder if you want to scale it by how big the current window is in general. Obviously, you don't want to be doing this in PV nodes as well. Yeah, so now we're getting none, actually. Now that I put it to and. First of all, you also have to be and I think that's it, right? I'm not being dumb, right? I'm like, no, it's backwards. I was doing this backwards. I don't know how subtraction works. My bad. Maybe you want to scale the margin with how big the window is. Like maybe margin equals beta minus alpha divided by 5. Is that a crazy idea? Maybe you want actually less, a fourth, and then you're kind of inside of one half of the window. Yeah, that sounds good to me. That sounds good to me. That makes sense to me. This album did end. That was very, very peaceful. I really like that. I really did. Now I don't know what music to play, but apparently we're going to watch an ad for Primate. I have to watch the ads, you know. It's like, it's only polite to watch the ads. Anyway, our cutoffs. Now we're getting 0. Do I not know how math works? Maybe not. Maybe not. Maybe I don't. Maybe I don't know how math works. Hold on a second. Yeah, Am I crazy? I'm confusing myself here, but I think that that's correct, right? I think. I think. No, that doesn't make any sense. That makes literally no sense. That literally makes no sense. Makes literally no sense. Never mind. We're not gonna do that. Am I crazy or? Oh. I see. I see. I do see. I do get it now. Okay, well then let's not even worry about that. Or we can take in the PV node thing as an argument, but no, we still are getting no cutoffs. Do I suck at math or? I mean, maybe it just literally doesn't. We could also add the core hist to here. We do this, and then we try that, and maybe that'll help us get I'm kind of worried that I don't know, that our eval is not going to get within the window enough. Because this amount of cutoffs is just not good. Hmm. 800. We could also test it without a margin, just to see if the concept is working. Oh, also, I'm not... It shouldn't matter if I return, I'm just testing. Are we getting literally less there? How does that make any sense? Probably because I removed the return. That's probably why. Yeah, I think that we might just struggle getting within the bounds without extra stuff. Wait, hold on. No. No. Yeah, I kind of wonder how far we're off. And so I'm just gonna like literally just lessay. I'm just gonna print out where we're at. I just want to see how far we're outside of the window. We might just not have enough stuff incrementally available to get accurate enough that we would fall inside of the window, which sucks. That does suck. We are going to get a lot of printouts right now. That is true. Yeah, we'd probably just like literally have to put some of this stuff above. Okay, so let's take a look. Maybe it is, or yeah, I think it is, or actually, I think it is. I think you have a big margin, and then or it. I think is the idea. Yeah, I don't know what I was thinking with this. It should be like 50. It should be just a large margin and then or. I don't know why I was overcomplicating it. That makes sense. Yeah, because the idea is you're either winning by so much or losing by so much that it doesn't matter. It's like a futility thing. But yeah, now we're getting a huge amount. We're getting pretty much every single one. That's every single one, right? 850. Yeah, that's every single one. Oh, because we didn't add the margin. My bad. Yeah, instead of trying to be inside the window, you're obviously trying to be outside of the window. So it isn't an aspiration thing at all. It's like the opposite. It's like the opposite. Okay. So now we're getting about 500,000, which is about half. We are slow, though. That's without a doubt. I am kind of wondering maybe we shouldn't be hashing lazy evals. So maybe we want to also return a boolean that says if this was lazy or not, and then we just don't hash it if it wasn't. I think that that's what I'm going to do. But yeah, it does seem like not very fast. Does not seem very fast. So there's a couple of ways we could do it. I literally think that the easiest way to do this is to just literally have a pointer to a boolean. That's what I think. There you go. And if not lazy, then rehash. I think that makes sense. Oh, that's actually a pain. We'll just type it out again. It's also maybe a thing where we have to tune the margins as well. We're also going to have, once again, another error inside of here. Yeah, it may be one of those things where I just have to tune the margins myself, and it's not going to work well until I do that. But it doesn't seem to be speeding up our search at all, which is not a good thing. It's not a good thing. It's not a good thing. How are we're at? Here we had pretty much everything. I wonder if we're not supposed to be doing this in PV nodes. What I was trying to, figure out earlier. Our evaluate definitely went down. It just doesn't seem to be making us go any faster, probably because we're not cutting off as many nodes as we would be otherwise, which is kind of sad. Yeah, we might have to just like tune the margin. I don't know how big that this is supposed to be, or if we're supposed to scale it with something. Beyond me. Raising it did seem to speed us up a little bit. So I think that the margin just needs to be tuned. Is it crazy, or are we getting more than before, though? We should be getting less if the margin is higher. Say anything about PV nodes in the... We still are getting a lot. Like, this is a lot, you know. It is a lot. I don't know what the typical I'm gonna look at some of these the forum posts about it. Just to kind of see what other people are. Okay, so I see a post here that there's a perfectly safe way to do it. If at some point the score calculated up to that point is outside the alpha beta bounds by a margin larger than the maximum value of the remaining evaluation terms, it is safe to return immediately. I see. I see. So I guess the goal... Why are we getting more? The higher I push the margin. It's like... Maybe it's just interacting with other pruning stuff, and I'm being tweaked out about it. I see. So people are saying, basically, to tune it based on the highest as it can go for the rest of the evaluation parameters. So I would have to calculate that, and that's kind of difficult to calculate. I would have to literally add up all of this. Actually, it wouldn't be that painful. We could add to search data a highest KTV thing, and then just like literally track the highest KTV that we get, and then just print that out and then see what that would be like. Basically for each of our evaluation parameters, and that's probably what we should do. So that's what I'll do. I'm trying to figure out if we want to scale it by mg or eg. Uh, yeah, we probably should. I mean, this is, at the end of the day, this is literally just for debugging purposes, so... By the way, I'm just doing KTV just as the proof of concept for this. How do I do this? So... Um... And you have to do this for basically everything. Except, you know, we don't have to do this for just KTV. What we could do this for is like literally everything all in one. We could get away with that. We could. So this is just going to be... So instead of this, let's just do literally all of the terms that we have here instead of just KTV. So this was... Let's just call it Matt. Well, it includes this. Okay. So turn all of these to EG. And then just use that in the formula. Oh my gosh. Okay. So we are looking for the highest Matt reached, and so we will literally just check if Matt scaled. We want the absolute Matt scaled is greater than the highest Matt reached from our search data. Then we will literally just print I'm lazy, I don't care. There you go. Now all we have to do is initialize that to 0 at the start of our search, and we can literally just like, you know, try and get that value. And that value will tell us about how much our lazy should be. Is this computer programming? I guess so. I am on a computer and I'm programming. I'm not programming a computer though. That would be kind of crazy. That would be insane. What did I just call this? I just called this something, and I forgot what it was called. Okay, it's called highest mat reached. Okay, so now we're gonna see, we're gonna be assaulted, frankly, by a lot of numbers, but all we're trying to see is how high this value goes, just to get an idea for what our. Oh, also we should turn off lazy evaluation while we're obviously testing the margin for lazy evaluation. That is something that we should do. That is something we should do. Happy New Year's to you too. Happy holidays. It is 2026. Okay, so these are some pretty high ones so far. So we did reach 600. 500, 900. Jeez. Jesus, dude. Jesus. 900. 1,000. Oh my gosh. Oh man, you hate to see that. 1622. Basically what that means is that our margin for lazy evaluation has to be pretty high. It has to be pretty high. Pretty ridiculously high. Because our king safety is exponential. Which is exactly what I was worried about and what they were saying on the forums. More bugs this year, more growth opportunities. I need you as my life coach. Oh my gosh. Okay, so it looks like 1622 was the highest that I saw. Yeah, that's an insane margin, man. That's a nuts margin. You hate to see it. Okay. Yeah. I don't think we're gonna get higher than that. That was an insane value for sure. So 1622 it is. We actually have to go to like 1700 because we also have to consider all of this other stuff at the bottom. Estimated around that much. So let's see. I mean, the benefit will be literally we're never going to get a cutoff at that value. There's just literally no chance that we get a cutoff at 1622 or 1700. Do I have a day job right now? Not really. I live in a kind of town where there isn't any programming stuff, so I kind of want a remote job, but it's kind of hard to get people to trust you, I guess. I'm not like a well-endowed programmer, you know. Yeah, we're getting nothing, which is so sucky. Really, really sucky. Yeah. Yeah, of course you could cheat it and make the margin like less, like but they said that this is The thing is, I guess you could technically do king safety separately. Calculate it. Oh no, but then we do add this king threat here as well. So you can't kind of do this in 2 passes. I mean, you could, technically. The idea is to early out. So technically you could just like do king threat separately from the actual material eval for the mobility and stuff. And we could take that out and do that separately. And then basically do the mobility stuff in a separate stage and the threat stuff in a separate stage, and then just early out before we hit the king safety. We would have to do that, we would have to make another function, I guess, with this. Which I guess is completely fine. It's completely fine. It just is kind of a pain. Not gonna lie, it's kind of just, annoying to have to make another function with pretty much the same parameters, and then we'd also have to measure how much that stage is in. Well, no, we know that it's 1700, so 1700 would still be the early out here, and then you would have the material mobility stuff, and then we would need to measure everything after the material mobility, which I'm assuming would still be big. Yeah, in that case, I wonder if you just want to get the king safety stuff over with, since it can be so big, and then do that before the mobility. I think that's probably what you do. But that's kind of annoying too. Yeah. Yeah. You would need to make it a separate function. I'm not even sure why we have it in the same function in the first place. They are 2 completely different things. I'm pretty sure that they use completely different masks. Yeah, I think so. So we can take it out into a separate function, sure. And the idea is that we basically are staging our lazy eval. So we're going to do the king safety first so that we can early out with more confidence before we hit the mobility, is the idea. And we call it king threat because that's what we call it in the engine. I don't really remember what we need for this. We should have actually just like copied this. It's not going to be the entire thing, but we're just going to copy like half of the parameters. There is no music. I know. I will get on that in a sec. I don't think that FPA and EPA, the threat stuff we don't care about. Yeah, I think it's just that and this. Okay, now the annoying part is we have to copy this. I think this is everything we need. We don't need F pawns and E pawns, I think. I think all that stuff we need. And And then we just need to do, I'm pretty sure that it's literally just this mask. And then we can literally just extract all of that stuff from this function. And so we don't actually have to like touch it. Okay. So we're basically just splitting these functions into two, because there is no real reason for them to be one in the first place, I guess. Okay, so hopefully we did all of this correctly. I don't see any, you know, squiggly red lines, so I'm going to assume that it's fine. And we can just get rid of everything in here, I think. Now, we do need enemy king square apparently for that, so I need to get that. So we are technically doing double work, but let's not worry about it for now. I do have 12 more issues, so this is something else. So we can technically loop through. It's not that big of a deal. We can technically loop through and do that. It's really not that big of a deal. All that piece of code is saying is it literally just if we overlap the king zone, we just add a bonus to the king threat. It's literally what it is. That's there we go. Okay, so now that's exactly one-to-one with what we had previously. Okay. Now we can get rid of KTV from there. And we don't really need all of the attack mask, but for now, let's just keep it what it is. Okay. This we can just this whatever. Now we have to get rid of this in here. Yeah, now it's kind of now it's kind of annoying to write the function signature for this function is quite large. It's quite a large function signature for sure. It really is. No, bring that back. I messed up. Oh no, I didn't mess up because I deleted it already. Oh, regret. I have no clue what order these are supposed to be in. I've genuinely no clue. And it's not giving me the function signature. Oh, you jerk. You jerk. Tell me what's in here. Okay, side. Okay, no pawn attacks, no weak squares. All that stuff. And then we just end with the... Yeah. Okay, now we just need to do this for black, and then oh, the worst thing is that we have to actually switch all these variables around. That's a bummer. That really is. Really is. There we go. Fantastic. Now, I think this is correct. Oh, wait, we don't want to do that. We just want to suffer for a little bit here. Okay. Now now that we brought out king threat separately, what we can do is we can do exactly what we did here and then early out again with a different margin, right? And so this margin, we will call this the S margin, which is just the static margin for the beginning, and then this will stay 1700 because that's about what the rest is. And then we will have the next margin. We don't really know how much the next margin is going to be, but we'll just call this the M margin, which is for material, and we will do this again. We are going to have to calculate what this is. I'm going to assume that this is going to be about 100, something like that. I'm not entirely sure, but we do have to do this. The thing is, right? The thing is, right, that what am I saying? Yeah, we have to get rid of this. That's what I'm trying to figure out. We have to get rid of that. I think that that's it. And now we just have to do exactly what we just did. We also have to disable all of this stuff while we're testing this. And this will tell us, you know, what the rest is. We should really just include the rest, but we can just estimate the rest. It's not that big of a deal. I mean, this is like about 20 to 30, depending on what we have tuned. And then this is about 30 to 40-ish. $125, $126. That's the highest so far, is like 126, 130, 132. So I'd be comfortable at like setting it like 170. Yeah, 170 is probably what you would set it at, something like that. And I think that you probably do want to hash this. Since we're being so safe, there's literally no point in not hashing it. And so I think I'm just going to hash them, not worry about it. I think it makes sense to do the king threat first because it's so large that there's no way that doing the mobility first would net you any gain. So now we see like the true lazy is 30,000, 300,000. That's actually quite a bit. That is quite a bit. I'm happy with that. I'm happy with that number. I really don't like finding B1C3, but I don't know if that's necessarily the fault of lazy evaluation, to be honest. Our evaluation barely went down, unfortunately. I do kind of think maybe we can lower the margin to be less ridiculous, for sure. But yeah, it is quite big still, even though we are lazying. And that is because we do still do the king threat, you know, and our margin is 1700 before we hit the king threat, you know. And so I mean, they say to be 100% safe, you should do the sum of the rest. But since the king safety is exponential, you know what else we could do? We could just like literally cap king safety. We could literally cap king safety. Yeah. That probably is the best way to do it. We get 300,000 now. I don't know. We are getting the exact same amount as we did before. With that, I think the best idea is to cap it. And so what is this, 170? So what's the difference between 1700 and 170? Let me think. That's that's 1530. That's 1530. So that's our max. Why not just cap it at like 900? I don't even think 900 would be enough. I don't even think 900 would be enough. Let's just try 700. I don't know. And now all we would have to do is literally just add add to 170, the 700, which brings us to 870. So that's what our new margin would be. So let's see if we get any more cutoffs. I doubt it. You would probably need, yeah, a much smaller cap. Hard to say. Hard to say what I should do. We get exactly the same amount. Yeah. 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 Let me make sure that I'm doing this right. Yeah, I'm using, oh, also that. Also that. Made a big mistake there. I don't think that that was affecting it at all, but maybe I should give it a shot. We could move the cap lower. We can move the cap lower from 700 to like 200. That's like really low, but maybe it's fine. I don't know. I don't know how much the exponential values are important. Maybe they are important. I don't know. Let's try with 200. I am going to dip out here soon. I know I've spent kind of most of today just trying to figure out margins and stuff, but that's a big part of doing this. It's a lot of fun. Just figuring out margins. Wow. 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 Really? Really? The exact same amount. Yeah, exact same amount with that margin. Maybe we maybe we shouldn't be using core hist before we do it. I don't know how much core hist could be, but I don't know. Just kind of spitballing, I don't know. Yeah, I don't know how low that margin would have to be to get cutoffs. Like, seriously. It would have to be so low. 200, and then our max would be 100, which is like ridiculously low. I don't know about that. Yeah. Well, it's what it is. Maybe I wrote a bug somewhere. Or maybe it just literally is that. I don't know. Maybe I wrote a bug. Or I don't know how to do math or something. Yeah, I mean, we can't really go any lower than that, so... We cannot go any lower than that, unfortunately. Oh, wow, I'm being... Oh no, I'm not being dumb. I'm not being dumb. I can try it with no core hist, I guess. You know, it's worth a shot, although I just, you know. I really wanted this to be some big gain, but I don't think it is going to be, unfortunately. Yeah. Yeah, I mean, I think that I actually programmed it right. I just don't think it's going to work. We can't go any lower than 270 and capping it at 100. Realistically, there's just no way. That actually did make the number go up. We're at 600,000. That's quite a sizable amount. That is quite a sizable amount. I wonder why core hist makes us not go within the margin. I wonder how much core hist is. I mean, it definitely caps out. I think it caps out at like 256, right? So that's interesting that has such a big impact. 600,000 from I let this run for a while. From 300,000, literally it doubled at depth 10 without core hist in the thing. Interesting. I have no clue why that would be the case. Maybe we do this not hashing. Maybe that has something to do with it. We tried not hashing again. So we didn't try this two-stage without hashing the lazy stuff. I don't see why you wouldn't be able to hash the lazy stuff, but Now we get 500,000. And a different move too. It's interesting. Well, no, the same move as when we didn't core hist it, but yeah, I'm definitely gonna have to do more testing. But the 300,000 is really annoying. The 300,000 is really annoying. I wonder if I did all of these variables correctly. I think I did. Yeah. Yeah, I think... Well, yeah. Anyway, it doesn't seem to be that big of a speed up, you know, to be honest. Anyway. I'm going to run some proper SPRT tests on everything that I implemented today. And, you know, that's going to be a pain, you know. It's going to be a pain. But if you... Yeah, we're still getting this many. If anyone is interested in the source code, I will be updating that as soon as I get some of this new stuff situated. I hope that this was educational, instructional, I guess, you know. Today we implemented the rest of the core hist stuff and the hashing per piece type. We also implemented we implemented some of these lazy margins and figured some of that stuff out. So that's cool. Yo, what's up? Sorry, it's hard to read names on this other screen. Stockerus. I'm doing this all in C. C is the language that I code in. Pretty much exclusively. I just like the simplicity. But yeah, I think that's pretty much all I wanted to implement today. Unfortunate that this isn't a big speed up for us, but once again, I have to do some SPRT testing to figure out, you know, if any of this was an elo increase. I'm not really sure yet. According to what people that are much smarter than me say, it should be a good thing that we did. C# or C++. And I'm trying to use C#, and you are really good. I use C. I guess I'm okay. Yeah, I'm making a chess engine. It's a part of the chess engine kind of series I'm doing. I guess the idea was to be a bit educational, since I made a chess engine before. And I plan to make a video on it soon. It does seem like 14.1, and 14 is the new build with core hist and lazy eval, which is what we implemented today. I probably have to play around with the margins. I'm really not sure about capping king thread at 100. It seems really sketchy, but having it uncapped is probably not the best idea either. But you know, you kind of do want king threat to get really high. And so, yeah. Yeah, it is winning. So, uh, that is pretty. I am happy that it is winning, even if it isn't a big speed up. Elo doesn't necessarily mean depth all the time. It's something that you got to realize. Sometimes it's worth it to have less depth, but a more rich history in your search. So, um, yeah, um, yeah. I think that I'm going to take a break for now, and I will. I'll see you guys soon. I don't know when I'm going to be live next, but if you're new here, you can join the Discord, um, and chat with all the people about programming stuff. I will probably have a video out soon, and if you want the source code, you can look at the description, but it's kind of really outdated. But I'm gonna update it as soon as I have the time to get rid of all these ugly comments and stuff. So that's on the to-do list. So, um, yeah, I have to go so that I can run a much more comprehensive test with more games happening at once. I can't do it when I'm streaming. So, how to join Discord? I think the link should be in the description. If it's not, let me know. I think !Discord also works. I can also probably get you the link right now. If you need it. I think I can. I can give you a link if that doesn't work. It's this link. Um, anyway, um, yeah. At this point, with the chess engine, it's getting Elo with the chess engine is much more painful than it was in the beginning. You know what I mean? It's much harder now than it was to improve in the beginning. That's kind of how it gets with the chess engine. Is you get to a point where it's like the gain is so minimal for the work you have to put in. But I think that that's also like kind of the challenge of it, you know. All right, thanks. Hope you have a good one. And hope to see you in the Discord. All right, peace out, guys.